Hello and welcome to my second Physics 2212 lab. So today we're going to talk about the purpose of this lab, which is to discover the behavior of electric charge and mechanically charged tape using a refined calculational method. So today the methods and principles are exactly the same as they were last time. Basically, everything revolves around Coulomb's law, which is a relationship which basically states that electric force is proportional to the magnitude of the charge of each point considered and inversely proportional to the square of the distance between the 2 points. So the main result that was observed in this lab is that by mechanically charging a piece of tape, it is possible to observe a visible deflection of the tape when exposed to other charged objects. The charge that was found previously was about 9.8 times 10 to the negative 11th coulombs, but the actual charge is much higher at 4.1 times 10 to the negative 8th coulombs. So the main physics ideas we're going to talk about are electric force, which will be used to calculate the force applied in this situation, and a gravitational force, which is basically a relationship which states that the force applied by gravity is directly proportional to the mass of each object that is involved and inversely proportional to the square of the distance between the center of masses of both objects. So because this is in this experiment, that will be used to calculate equilibrium against the electric force. So for this experiment, two tapes are going to be charged by layering them on a base tape and then taking them off to cause a mechanical transfer of charges. These tapes will then be checked for charge by hanging them off of a table and moving a charged object nearby, and in turn observing any deflections which might occur. So finally, one charged tape will be held under another, and as both are charged, the tapes will repel each other, causing the upper tape to hover. So for this situation, the system is the upper tape that's getting lifted, and the surroundings are the lower tape as well as Earth for the purposes of gravity. So the initial conditions are that two charged tapes are created through a controlled unsticking process. They will have approximately the same charge. So for assumptions, we can assume that the tape can realistically be modeled with a finite number of point charges in a straight line. Only forces acting on the tape are gravity and electric force. There's no air resistance involved. And that both U-tapes have identical amounts of charge, which are distributed evenly along the tape. So to simulate this situation, I built this coding model, which basically calculates force based on the distance between the tapes, the mass of the tapes, the estimated charge from the point model, but instead of using point charges, we use a line of point charges to more accurately simulate the behavior of a tape. With the given initial conditions, charge and mass are evenly distributed to each point mass. So forces are calculated for each point, and then all of them are added up together to get a total force that's applied according to gravity and by electric force. So here's what that code looks like. Basically, we're going to start with defining the mass and the estimated charge on one of the tapes. And then we are going to use a system of code to find the electric field that's being generated by the lower tape. And then we're going to multiply in the charge of the upper tape to ultimately find the force. That's done in the second area. And then that's done for each of the point charges, and then they're all added together. So to compare the results that were achieved from this experiment versus the previous experiment, several orders of magnitude in difference of electric force and gravitational force were found. So 9.8 times 10 to the negative 11th coulombs was originally calculated. However, 4.1 times 10 to the negative 8th coulombs is more realistic. The electric force is very close to the gravitational force in that case. So the potential sources of error are that the mass of the tape is estimated based off of length. The handling of the tape could cause a change of charge, so likely estimated in charge is not realistic. For the first situation, the small deflections, small deflections could result in misidentifications of the charge of the tape, and that the electric force doesn't uniformly act upwards. So what does that mean? So the tapes were simulated as point charges in this situation. So the charge that's required for the point charge scenario is going to be much low. Well, the force required to make a point charge hover is going to be much lower than that of a tape, because the electric force applied to a tape is not uniformly acting upwards. A lot of it acts sideways. You could see that in the visual that I coded earlier. So likely, as a result of that, the amount of charge that you need to apply a satisfactory amount of force upward is going to be different for a point charge and likely lower for a point charge than will be for tape. Other than that, that should be everything. Thanks for watching.